with a Freedom account is create one. So I start with a controlling do fixture up at the top, and that's my one namespace word in the whole test, and it's in a setup so that all the tests will inherit that. And I put the create account named up in the setup because we use that for all the other tests as well. Really, for this particular test, it should be down in here. You can see I said C setup above there. So I say a new Freedom account can be created and named. So we have this create account named free at last. And initially there's no categories, and it doesn't have any, or it has a balance of 0. And so we can run that test, and that one I have passing so far. So a quick tour of the code. We've got a do Freedom account, and it has a create account name method that creates a new account with that name and makes that our system under test, so that then we can start delegating directly to the account for the other stuff that we want to do. And I've got signature for here that says, oh, that I have a method that takes a string as a parameter. This is the only one that we have a signature for at this point. And in my domain, I've got an account, and I can create it with a name, which is what my code did. And I initialize it where I don't have any categories. And its total balance is just a new money. Money is a domain class that I have. We'll show you that when we get to it. But basically, I'm using a whole value in the table rather than primitive type like a float or a fixed point or something like that. And categories just returns that categories instance variable, which was initialized to an already collection. So when I create a new account, basically I get no categories and a 0 balance, because money new returns 0 balance. And that's that test. So I've got kind of an initial set of domain code and very little bit of fixture code to make that test pass. Okay, so the second test is, well, okay, once I have an account, I want to define some categories in it. So I've got my setup up at the top again. And so I say categories need a name. I also need the amount of the expected expense and how many times per year that expense will be incurred. So some stuff you pay once a year, some stuff twice a year, 3 times a year, quarterly, something like that. So I create some example categories in there, and the amount that I pay and how many times a year I pay it. And then I check my categories, and I check what their annual expense would be. So, $2,500 once a year is $2,500 a year, but this is $600 a year, and that's $2,000 a year. And so I'm testing that I can figure out what the annual expense of a particular category might be. Okay, so let's go look at fixture code again. Back to my controlling do fixture. Well, there's add categories, which is what that table had in it. Should actually make this a little bit now. You can see both at the same time. There you go. Okay, so add categories just makes a new setup categories fixture and sets the system under test right away. So that setup fixture is going to have a system under test that it can work with. And this is what I've talked about, where I've got, the do fixture has this one instance variable, and I pass that around to all the other fixtures, so I don't have any static variables laying around anywhere. Gilad would be proud of me. No static state. So the setup fixture just has this, name amount times per year, and it just says self account, add category, make a new category with those instance variables, and add it. That's pretty simple stuff. I could show you the category thing, but it's just a basic instance creation method. We'll probably run across that in a bit. And then the last thing here, categories. Go back to our controlling do fixture. Well, there is no categories getter there, so it must be calling that on the system under test. And sure enough, we've got a getter on the system under test that returns a list of categories. And because that's a collection, it's going to treat that as an array fixture, automatically auto-wrap it in an array fixture and interpret that table using that array fixture. And you can see on category, I've got a name and I've got an annual expense, which actually does some computation now that we're testing by this test. pretty simple computation, but it's there. And again, we had to do the signature for thing here. Name is a string, otherwise it's a money for now. Python has a slightly more, and Python has to do the same thing with this type mapping, and it has a little less verbose syntax for initializing dictionaries, which is essentially what this is. I do it a little differently just because I don't want to have to explicitly list every symbol if I don't have to, every selector. Okay, so that's the first two tests we've got. Again, I realize I'm kind of breezing through this a little bit, and hopefully as we go through the interactive stuff, you'll start to get a better handle on it. So this is the test that isn't passing yet, and so one of the concepts you have is every time you get paid, say, you make a regular deposit into your Freedom account. That's how you fund the thing, so that you've got the money there when you need it. And so first we need to say, how many deposits are we going to make in a year? Because that tells us how much each deposit needs to be. Now, I happen to get paid every 2 weeks. In fact, I think I got paid today. So every 2 weeks, I want to make a deposit into my Freedom account, and I want to basically deposit 1/26 of the total expense of each category into my Freedom account. And so this test is telling us about that. So again, we set up some categories. I might want to move this up into setup at some point, or maybe have a separate setup for these tests that use the same subcategories, whatever. I want to make a regular deposit. I want to test that I've got these categories and that they now have this balance. I didn't pick numbers that worked up to nice round numbers. I kind of used the same numbers I had before, and 26. And I check my total balance. And then using the pattern I just talked about, the describe, demonstrate, develop. So I described, and I demonstrated. You know, there's my total balance. And now I'm going to develop that a little bit and say, okay, let's really explain how a regular deposit amount for a category is really described, and give some examples. And so this is more of a business rule test where, you know, if this is the annual expense of a category and this is how many deposits per year, well, that's how much the deposit amount is going to be, and so on. So these are more examples of how do I compute these guys. So I'm kind of developing it a little bit more. I could have ordered it differently, but so this is kind of the more complete, understandable part of the example. And then this is just developing it a little bit more and saying, okay, here's some more examples. I want to make sure that you get those right, kind of thing. And so if we run this test, I have not made this one pass yet. This is our first exercise to do. Gee, it fails. I get one wrong and a whole bunch of exceptions. I have done some work on cleaning up the error messages you get back in the table, so it's understandable. We'll probably run across a few cases where they're not. And there's a couple I couldn't clean them up yet because I would fail some of the other validation tests just because they're very strict about what the error messages should be. But I'm still thinking about how to solve that problem. Didn't have time before I came to the conference, so I didn't. So the first table, well, we have this missing method, deposits per year, and do Freedom account. That seems to make some sense. We don't have that. So let's get that first table working. And what we actually want to do, deposits per year probably belongs in the actual Freedom account, not in the fixture code. That seems like a domain concept to me. So let's go implement that on account instead. I'll make a setter called deposits per year. That should likely be an integer. And for now, we don't need to do anything with that. Kind of do, Josh Karyevsky of Industrial Logic likes to call this story test-driven development. He calls these fitness tests story tests because they're testing a user story in XP. And so we're driving our development from these story tests. And you do your normal test-driven development kind of in the inner cycle of that. Okay, so let's try that, what happens. Here's one of those not-so-friendly error messages that I just talked about. In this case, if you look down the stack, what you see is this here. We've got a method signature that doesn't have a parameter adapter at the right spot. And what that means, what happens, the default implementation of method signature returns an empty method signature, and it's trying to find the first parameter type adapter, and can't because it doesn't, we have an empty one. So what this really means, and this is one of the ones I couldn't clean up without failing some validation tests, I'm going to fix that because this is ugly. It basically means we didn't implement the signature for for this deposits per year. And we'll do that over in our signature for our account. And what we'll do is we'll say if a symbol is deposits per year, and let's return a method signature with integer. An integer. And method signature is actually in the fit namespace, so we have to do that. I don't really want to import fit into my domain namespace, so I'm using the explicit qualification here. I could set a default package namespace on the fixtures package, which would probably make life easier, but I won't do that here. Otherwise, anything else is money. So stick with that, and that should clean that table up. It does. And there's nothing to check there. That's just basically setting up some data. Add categories we had passing before, so there's no problems there. Now we don't have a make regular deposit method. So we better have one of those. And again, that's a domain concept. That's not a test concept. So that should go on account as well. So back to our domain package. I'm just working, I've got tabs on two different packages here, just the fixtures package and the domain code package, which is why I keep flipping back and forth. We'll call this actions. It's a generic name. And have a method make regular deposit. And again, this doesn't need to do anything yet because we don't have any test that tells us to do it. That doesn't fail anymore. So now we have this categories table, and we've checked categories before in a previous test, but now we're saying, oh, it doesn't have a field balance, and that's because we didn't do that yet. Categories didn't need to have a balance in any previous test. So we're learning more about our domain. Oh, categories need to know their own balance, okay. Let's make that happen. So again, this is on category. Field, again, is a Java term, but I use it here because that passes the validation test. So categories need to have a balance. And I don't know what to return there yet, so let's just return a new money. Because it seems like a balance ought to be a money thing. And we'll have to probably go do a method signature again. Let's see if we get a nice error message this time. We didn't need to do a method signature. And the reason for that, I think, is because category, if its name is a string, anything else is money. So that was already done. We didn't have to do any extra. Whereas if we used a dictionary with every symbol in it, we'd have to go add that one too. But these are failing because we don't actually have balances there, and the total balance is wrong as well. So now we've got the exceptions out of the way, other than this develop stuff down here, which we'll get to in a minute. Now we actually have to do some work to make this pass. I didn't write myself a cheat sheet, so I'm flying by the seat of my pants here. We'll see how it goes. So a regular deposit in an account probably all we need to do for now is, well, let's think about this for a second. The total balance of an account should be the balance of all the categories. So maybe let's do that part first. We can figure that out pretty easily. So let's go into the account and total balance. And instead of just returning a new money, we should probably do something like categories, spell that right. Inject money new into sum each, sum plus each. Okay, so that looks more like what we're going to want to have in here. I'm going to not necessarily write unit tests for all this stuff. Just oh, that's interesting. This is another one of those weird error messages. And I've got money, and it has a plus, but freedom account category does not understand. Oh, I know what it is. That's just dumb. I don't want to add in the whole category. I want to add in each category's balance. Like I said, I was flying by the seat of my pants. So I'm still getting the wrong answer, but I'm getting it in a much more intelligent way now, because categories don't do anything with the balance yet. So I just kind of picked off the easy part there. I should actually show you money a little bit just so you see what we've got here. So you create it, you can create it on the cents or dollars. It just stores whole numbers of cents, basically. There's the fit parse method that makes it work in the tables. And use a little bit of regex matching. You can have an optional dollar sign on the front, at least one digit, optional decimal point followed by a number of digits. That's the money. And then to parse it, we check whether the first character is a dollar sign. If it is, we pull out the rest of the string, otherwise we use the whole string, and then we just use numbers fit parse method to parse it as a number, and that's what we return. And that, we treat that as a dollars and create an instance. And we implement equals over here, check whether species are the same and the cents are the same. And we've got hash, of course, because we need that. And then some of the basic arithmetic is implemented as well, which we use. I'm not going to spend a lot of time on money. I've got some unit tests for them that I'll pass. So, but the fit parse, I use the default toString, which is implemented here. Just prints it out using dollar sign and so on. And so that's how these guys end up looking. You know, this got parsed using fit parse, and this got printed out using fit toString. And the comparison was done with the equals method that I implemented. So that's how you use your domain classes in your tables. Don't want to gloss over that too much, but that's how the money guys work in here. Anyway, we need to make regular deposit do the right thing. It seems like for regular deposit right now, all we care about is make sure the category balances get updated properly. So when we make a regular deposit in an account, let's just tell each of the categories to make a regular deposit. And actually they need an extra piece of information that the account has, which is how many deposits per year are we going to make. So we better pass that in there as well. Call it a frequency. You could call it times per year in here. Actually, I didn't because we didn't do this yet. Deposits per year. Make it match the setter that we put in there. Okay, so we're going to ask each category to make a regular deposit based on a certain frequency. That isn't there yet. That wants to actually be an instance variable that we set here. And if we were to run that now, we'd get an unhandled exception because we don't understand make regular deposit frequency. So we better go implement that. That sounds like an action. And I don't actually have money divide implemented. So let's do balance gets balance plus self regular deposit amount. I don't know if that's the greatest method name in the world, but I'll stick with that for now. Balance is not defined yet, so that's better be an instance variable because we need to return that here. And we probably better initialize that to new because we're adding to it without running and failing right away. I thought it would be annoying, but I wanted to try it. I've seen people writing about having your tests automatically run every time you make a change. And I actually find I like it a lot more than I thought I would. So it's interesting. Now they passed me. I had broken them because I didn't have initialize implemented yet. So that's just, I'll put in a little plug for that extension. It's called sunit tools-auto-run in the content store repository if you're interested in playing with that. It's not perfect, but it was an experiment to play with the idea and actually like it a lot more than I thought it would. It doesn't work with the old sunit stuff, just with sunit 2, but it's there. So we have balance being initialized. So now if we run this, we probably get another unhandled exception because we don't have a method. Since I'm going to be adding now. Category does not understand. I probably forgot to return something somewhere. Yeah, I know, but I don't even have this regular self-regular deposit amount yet. So I'm not sure why it's complaining about that. Because it's in here. It calls money plus. I didn't think I implemented that method yet. Well, let's implement that and see what happens. And that should be self-annual expense times an integer reciprocal. Let's try that. It's probably still broken because I probably didn't catch what really happened there.
This is freedom account category make regular deposit frequency.
Yep. Which is here. That's right. This is a money new. It is calling money plus. Smalltalk wins again. It's not even calling that. Why not? Okay, obviously do something weird here. Let's look. It's not actually calling this. So we've got, we're calling make regular deposit, and then we're calling this on a category. Guess I should have had a cheat sheet, huh? In here. Got categories.
Get balance.
Balance should be a new money, yep. Why is it
Go
doing,
into that.
doing that? Shouldn't need them.
I understand.
Oh yeah, I should too. Yeah, never mind. My head's not in the right space. Yeah, it was, Sherry's right. God, it's a very binary keyword. There we go. Hammer passing. So we've got this last table to finish, but it's 3 o'clock, so let's take our half-hour break. All the refreshments are upstairs in the usual place, so we'll have to go up there. We'll reconvene at 3:30. We'll quickly get this last table passing, and then we'll work through writing some tests ourselves and making them pass. But this is kind of the basic workflow you go through. More complex business logic, you probably write your unit tests as you're going along, which I did do in some of the earlier stuff, and I'm not doing here because I'm a bad programmer sometimes.
What's that book you've got to talk
I will talk about that at the end, but I will.
about? Oh, all right.
Okay, I'll give you a quick. This is a book written by Rick Wugridge and Ward Cunningham called Fit for Developing Software. If you're going to do anything with fit and fitness, I highly, highly recommend this book because it really talks a lot about the philosophy of how the tool is intended to be used. There's some good examples in here too. One of the coolest things is where you can have 2 different sets of fixtures to run the same test. One set of fixtures can be working kind of at the domain level, You have another set that actually drives it through a UI or just under a UI or something like that. So you can test the same application with the same tests in two completely different ways just by using a different set of fixtures.
What's the slogan?
Fit for developing software. I'll have a link up at the end of the talk about it. But it's just with some pretty good examples in here. All the example code that they made available from here I actually have in the public repository. Again, I'll talk about some references at the end of the talk. Okay, so let's go take our half-hour break and be back here in a half an hour or so.